Hi, this is Chris, and we are on SAT Practice Test 3, Section 4, and we are taking a look at questions 12, 13, and 14 here. So let's go ahead and dive right into question 12. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? And this is really a vocab question, but when they talk about zeros of a function, zeros can be seen written in a lot of different ways here. Oops, I didn't mean to make that point at answer choice B. I meant to just point out a couple words. Zeros, it's really the same thing as saying solutions, or sometimes you'll see it as roots. Those are equivalent terms, and SAT can actually present those in different ways. So I'm going to put a big box around this and make sure that's something that you go ahead and memorize, because when you see a question like this, luckily, the good news is we don't have to do much math, but we do have to understand the terminology to be able to get this right. 5 distinct zeros just means 5 solutions or 5 roots. It's basically, in lengthier terms, a way of saying that there are 5 places that this graph will touch the x-axis. So let's go ahead and count. For A, we have 1, 2, 3, 4 distinct zeros. Not it. For B, 1, 2, 3, 4 distinct zeros. Not it. For C, we have 1, 2, 3, 4, 5, 6 distinct zeros. Not it. We already know it's answer choice D, but let's go ahead and count them. 1, 2, 3, 4, 5 distinct zeros. So again, for question 12, it's not really asking you to do anything calculation-wise, but they do want to make sure you understand the terminology here. When they say distinct zeros, they're talking about solutions or roots where the function touches the x-axis. Or another way of saying that is it's a zero because the y value, the value of the function, is equal to 0. Now let's take a look at question 13. So here we have h equals negative 16t squared plus vt plus k. The equation above gives the height h in feet of a ball t seconds after it is thrown straight up with an initial speed of v feet per second from a height of k feet. Which of the following gives v in terms of ht and k? So they give us an equation and they describe each variable. They tell us h, t, v, and k in this. But this is, again, one of those examples where really what we care most about is going to be the formatting of the answer choices, because this is our biggest clue. At a quick glance, we can see that they're asking us to solve for v in every answer choice. So let's go ahead and see if we can do that. Here we have our equation, which I will rewrite so that we can follow the math on it together. H is negative 16t squared plus vt plus k. So to isolate v, I want to move everything else to the other side. And I'm going to be subtracting k, and I'm going to be adding 16t squared. So this will be h minus k plus 16t squared on the other side to leave me with vt. And we're going to divide by t. But if I look in my answer choices, I see that sometimes they actually split it up, right? I see something divided by t and then another term where I don't have it over t. So instead of worrying about how that's going to be depicted at the end, let me divide everything by t individually. That'll make it a little bit easier for me to see where they came up with the different variations of the visual display of this result. So here, divide by t, and the t's here cancel, so I'm going to get v by itself. One of these t's next to the 16 will cancel out with my denominator, so I'll have 16t by itself, and then h over t and k over t, those might end up being combined in an answer choice. Let's check it out. But for right now, we have h over t minus k over t plus 16t And if we do each term by t, then we can see a little bit more easily here that, you know what, 16t would be the standalone term without a denominator, and h over t minus k over t, this can be combined, and they go ahead and combine that in answer choice D, h minus k over their common denominator of t plus 16t without any denominator, and that's our correct answer for number 13. Let's move on to 14, and here it says the cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost, C, in dollars, for H hours of phone use? Now these questions, whenever you have conversions, especially with multiple variables in place, they give us a cost, C, for H hours. We might know the conversion very easily for hours to minutes. There are 60 minutes in an hour. And that's not the challenging part of this. It's about putting the 60 in the correct place. So the easiest way to approach this is a great PAM question, pick, answer, match. It's a great strategy to use here. I call these PAM questions. You might have heard of it as plugging in or any other phrasing, but I call it PAM. It's an easy way to refer to these. And the reason that this is a great PAM question is because we see variables in our answer choices, and it's going to be variables in the answer choices on a question where the algebraic relationship is difficult for us to synthesize on our own. So let's see if we can use PAM. Let's pick an actual value here. So here, we want to pick a value for H. How many hours was this phone call? And we want to pick something that's easy to work with. So even if it means for a long phone call, I don't want to pick 0 hours. I don't want to pick 1.3 hours. So let's go with something like 2. Nice small number, still easy to do calculations with. So if we talked for 2 hours, let's answer the question. They tell us in the question that it's 20 cents per minute. So let's figure out how much that would cost us. A 2-hour call, how many minutes is that? So hopefully we say 2 hours is 120 minutes using that conversion. And that would be 120 minutes times that $0.20. And they are asking for C in dollars. So we're not going to use 20 in terms of cents. We're going to use 0.20 in terms of dollars. And if you do 120 times 0.20 for this, you can use calculator if you need to, but 120 times 2 would be 240 with the 2 decimal places. That's going to give us a total of, total of 24. So here we're going to have 2,400 with the 2 decimal places as $24 for this phone call. And let's see what that would match up with. Which one of these answer choices is going to give me 24 as my result when I go ahead and multiply this out? Well, for A, if I plug in a 2, the cost, I do 0.20 times, and you can probably already tell that 0.20 times 120 is exactly what we did here. So that will give me 24 with my 2,400 and my 2 decimal places. So that matches. That looks good. Let's double check. Answer choice B would give me, let's see, 0.2 times 2 for the hours. That would just be 0.4. This would be 60.4. Well, that's definitely not it. So no thanks to B. Let's try C. I would have 60 times 2, which is 120, divided by 0.20. And you can do this, again, use calculator when you have it to your advantage on any section. But in this case, you can probably already see that if the calculation I did was 120 times 0.2 to get the right answer, well then if I'm dividing by 0.2 instead, I'm likely going to come up with something different. And when we do the math on this, we actually come up with 600. So that's not equal to 24. And then lastly for D, again, we can do the exact math, but it's also important to take shorter steps when available. 0.2 times 2 would be 0.4 over 60. And I can probably already tell that that's going to be a really small fraction. So that doesn't look too appealing. If you use calculator to do the exact math on it, or if you were to convert everything to fractions and write it out, you actually get 0.006 repeating, which again, it's not 24. our correct match for this is answer choice A. It matches the value that we came up with by just plugging in a nice easy to use number like h equals 2. So again, don't forget about Pam. She'll be your best friend whenever you're dealing with questions that have variables in the answer choices of really difficult algebraic relationships. Using pick, answer, match is a great strategy to try to make that a little bit more manageable and something that we can oftentimes